All right, so on this particular test that you're going to take tomorrow, you have to plot the points in a coordinate plane, graph functions, evaluate operations with functions, determine even, odd, or neither, find the domain, sketch shifted and stretched functions as well. So there's quite a few things to go through, so we need to kind of move quickly here. First off, plotting points. Hopefully this is not too big of a deal for you. So you have to plot the coordinate a to -7, which means it would be to the right 2 and down 7. Second one is a -4, -5, which that quadrant there would be the fourth one. For B, -4, -5 would be here. This is the third quadrant. For C, 0, -3. That's not in any quadrant. And D, a -6, 0 is there. This is the first quadrant, and that's the second one. So there'll be a few like that. Hopefully you get those all correct. Some gift points, yes.
Do you want us to write like quadrants?
No, you don't have to do that unless it asks.
Okay.
For that part, yeah.
How many are on there?
You probably want 50 of them on there, but no, there's a couple of them like that. Can it be the whole test? No. All right, then you'll be asked to graph some particular functions. First one, it's a line, so you should solve for y first, or you can just use the intercepts. If you solve for y, you would get 2y equals 7x plus 14, and divided by 2 would get you y equals 7/2 x plus 7. And so you'd go up 7, and then the slope is 7/2, which means down 7, left 2, or up 7, right 2. And then you draw your line. It's pretty close to being straight. Oh, all right. This one here, what type of figure is it? It is not a parabola, because both things are squared. It is not a V. It is a circle completely. And the radius of the circle is 3, and the center is 0, 0. And so then you have that. Now really you should solve for, if you solve for y, you would get y equals plus and minus the square root of 9 minus x squared. And since you have your graphing calculator, then you can enter this into your equation, or into your graphing calculator to graph it. You'd have to put two equations in, one positive, one negative. The positive is the top half, the negative is the bottom half. So then moving over to this next one, which should help you with this one, what type of thing is this? Okay, it's a part of a circle because it's only the negative of it. And since it is x equals a negative square root of 9 minus y squared, you are going to get what part of the circle? The top, the bottom. It's going to be a side. Which side? The left or the right? The left side, because it's x that is by itself, that's not squared, and the y is squared. When y is squared, it's not a function anymore. So therefore, it's the same thing. We have a center at 0, 0, radius of 3, but we only need the left half. Yes. The negative makes it the left half. Positive would make it the right half. And then finally, our last one here would be, what type of a figure? Okay, it's going to be a parabola. And the center of our parabola is at 4, negative 5. And because it's positive, it'll open up. And then from there, you should go 1 to the right and to the left and up 1, 2 to the right and up 4, 2 to the left and up 4, 3 to the right and up 9, and 3 to the left and up 9. And you'll have each one of those types to graph tomorrow. Alright, then evaluating functions, there will be all different kinds of these. For g of 4, we would substitute 4 in for x. We get 5 times 4 minus 2, which is 18. H of a negative 5. Here, because it's this one, a negative 5 fits this interval. These things here are your domain. And a negative 5 fits that one. So then your answer is just going to be straight up 4. Next one down, h of a negative 2, same function. Negative 2 is still going to fit this one because it says x has to be less than or equal to a negative 2. So this is also going to be 4. Then we have h of 2. Well, h of 2 is going to fit the middle one because it is between negative 2 and a positive 3. So now you have to substitute it into 2 times 2 plus 1, so you get 5. And then lastly on this column, h of 5 would fit here because it's greater than 3. So then we have 5 cubed minus 5. And you get 120 for an answer. Moving over to the other column, f of a negative 3. We would have a negative 2 times a negative 3 squared plus 3. Negative 3 squared is 9 times negative 2 is negative 18 plus 3 is negative 15. If you're given some other variable to substitute into it, like f of a, then you just have to substitute it in and leave it. And then when you have f of a plus h, same thing. you can simplify this by multiplying out the a plus h, and you would get a negative 2 times a squared plus 2ah plus h squared plus 30. And then distributing the negative 2 would get you a negative 2a squared minus 4ah minus 2h squared plus 3. And that would be the simplified form of it. And if you have f of 1 over a, that would become a negative 2 1 over a squared plus 3. When you square 1 over a, you're going to get 1 over a squared. So then you will have a negative, and times negative 2 would get you a negative 2 over a squared plus 3. And for f of 2a, get that to start with. 2 squared is 4 times a negative 2 is a negative 8. A squared plus 3. And there will be quite a few like that on there. Probably more of these than more of the graphing where you just have to plot a point, unfortunately for all of you. Then you'll have someone dealing with the operations of functions. Sometimes just figuring out with f plus g of x. So here all we have to do is add the two things together. And combine the things we can. And the 3 and the 2 can be added together to get 1. If you're trying to do g divided by f of a negative 4, you need to figure out what both of those two values are, g of a negative 4 and f of a negative 4. For g, it's 5 times a negative 4 minus 2, which is a negative 22. F of a negative 4 would be a negative 2 times a negative 4 squared plus 3. And that's going to get you a negative 29. Because 16 times a negative 2 is negative 32. And then add 3. And then since you're dividing, your final answer is going to be a positive 22 over 29. Same with the g minus f of 2. Take g of 2 first, then figure out what f of 2 is second. So you have 5 times 2 minus 2, which is 8. And f of 2 is a negative 5. So then since you're subtracting 8 minus negative 5, that would be f of 3. This is a composition of two functions, so we have to just use the f function. But first figure out what f of 3 is. Squared is 9 times the negative 2 is negative 18 plus 3 is a negative 15. And then substitute a negative 15 back in. And that's 225, so 450 negative plus 3, so negative 447. And if we have f composition g of x, here then we just have to substitute this whole function in there. To get a negative 2 times 5x minus 2 squared plus 3. And then working through this and simplifying it down. Squaring this would get you 25x squared minus 20x plus 4, because when you multiply those two together you get a negative 10, and you're going to do it twice. Distributing then you'd get a negative 50x squared plus 40x minus 28. So then your final answer that's not 28, it's 8. Holy cow. Because a negative 2 times 4 is negative 8. And then plus 3 is negative 5. Now then, having to determine even, odd, or neither, you can put them in your calculator. Remember, if it's even would mean it reflects over that axis. Odd means that it reflects over this point. To actually determine it algebraically, you have to figure out what f of a negative x is. And also what f of the opposite of f of x is. So doing this, that's going to become a negative x to the fifth. That's going to be a negative 5x to the third. That's going to be a negative 2x and minus 3. This is not the same as that, so it's not even. Because for it to be even, these two things have to be the same. And then if you take the opposite of f of x, that would be a negative x to the fifth, minus 5x to the third, minus 2x, plus 3. And these two have to be the same for it to be odd, which is not the case, so this one would be neither. Looking at our second example here, substitute a negative x in. This will turn into a negative 1/2 x cubed plus 3x. These two things are not the same, so therefore they're not even. And then to check for oddness, you just take the opposite of f of x, which would be a negative 1/2 x cubed plus 3x. And now, since these two are the same, we say they are odd. So then checking this next one. Substitute a negative x in. You would get x to the 4th minus 3x squared, because when you square an odd or a negative number, it's going to be positive, and plus 5. And in this case, these two things are already the same, so we don't have to check for it being odd, because then we know that it is even. And in our last example, going through this whole thing, that would become x to the 4th, still minus 2x squared, and it would be minus 2x minus 3. These are not exactly the same, so they're not odd. And if you take the opposite of f of x, you'd get a negative x to the 4th, positive 2x squared, negative 2x, and a positive 3. These two things are not exactly the same either, so then this one would be a neither. Like I said, you can see that graphically because it won't reflect over the y-axis, or it won't reflect over the origin. So you'll get a couple like that. Okay, then figuring out the domain for a function. Here it would be just all reals, because you can substitute anything into this. In this one, your denominator can't be 0 ever. So you have to take the denominator, set it equal to 0 and solve it, and you will get x squared equals 16, so then x equals plus and minus 4, because you take the square root of both sides. And so then your domain for this one would be all except plus and minus 4. No. And if you want to write your domain like this, that is fine. Otherwise, you would have to write it this way. infinity to a negative 4, then from negative 4 to 4, and then from 4 to infinity. You can write this. I'll accept this. That's fine. It does the same thing, doesn't it? All right. All right, then this next one. When you have a even root, fourth root, square root, this has to be greater than or equal to 0. So 2x plus 3 has to be that. So x has to be greater than or equal to negative 3 halves. And so there's your domain. Or you can say a negative 3 halves to infinity. If it's an odd here, then it's always all. Then you can put anything in, so it's all reals. It's only when it's even that it's going to be limited. And then here, same thing. We have a square root of x in the denominator. So now x has to be greater than or equal to 0 first off. But then because it's in the denominator, we can't have it equal 0. So it's just going to be that. Do it just like this one, except get rid of the equals part. And then you'll have a few where you're going to have to sketch a graph. So here's our function drawn in red. For this black one, what is happening to it? Is yours different? Where is it at? Yours is not the same. Up 4. Yours is up 4. So it's like there. There. Like so. Okay. So then, what is this one going to do? What's going to happen? Which values are going to be affected by this 3? The x's. The x's are going to have to be multiplied or divided. Because it's with the x, it's got to be divided by 3. That's supposed to be x's. Sorry. Because it has to be the opposite thing. So this coordinate here, which is 0, comma whatever, is still going to be here. If you take this coordinate there and divide negative 2 by 3, you're going to get a negative 2/3, which is right there. If you take that coordinate and divide it by 3, that's going to be a positive 2/3. So right there. This coordinate here, which is a negative 4, is going to be a negative 4/3, which is right there. So it's going to look like this. Problems? Because it's going to compress it together. Which numbers? The ones for the black? Okay, so, because you know this coordinate right here is a negative 2, comma 3. Here we're saying that all the x's have to be divided by 3. So we'll take a negative 2 and divide it by 3, and that becomes a negative 2/3, and the 3 stays the same. This coordinate right here is 0, comma 3 point something. So when you take 0 divided by 3, it's still 0. If you pick another coordinate like this one right there, that's a positive 2 divided by 3, which is still, it's 2/3, and the y value is still the same. Or if you pick this one here, 3 divided by 3 is 1. So it's going to be right there. Just pick some coordinates on the graph, and then you just have to take all the x values and divide by 3. Okay, so our second one, what's happening to it? Okay, it's going to go right 2 and up 3. So this point is going right 2 and up 3. And that coordinate is going right 2 and up 3. And this point is going right 2 and up 3. And so that is how that one will look. For our green one, what's going to happen? Okay, the y's are going to be affected. They have to be multiplied by 2 because it's not with the y. And so this coordinate of negative 2, 3 is now going to become a negative 2, 6. This coordinate that's at a negative 4, 5 is going to be a negative 4, 10. This coordinate here, oh, that one there is what? Pretty close to the same thing. It's going to be right in there. So it's going to look like that. Twice as tall. And then this last one, you have to take the absolute value of x. So this part of it's not going to change. It's still going to look like that. And now instead of a negative 2, 3, we are going to be at positive 2, 3. So that part's going to go there. And instead of it being at a negative 4, 5, we are going to be at positive 4, 5. And so it's going to look like that. Which it's not going to affect this one, but if you had a question where it went to draw absolute value of f of x, then that would affect all the y values and they would all become positive. In this case, because it is a completely positive thing, it's still going to stay the same. But if it was something that was down here like this, and you were supposed to draw this differently, it would look like that. Because this part of it all has to be flipped up to the positive half. And so that's tomorrow's part of the test.